Today, we're diving into something that is literally changing how we interact with artificial intelligence. We're going to break down MindStone Agent and its layered continuity architecture. Basically, we're talking about how to transform AI from a disposable, use it once and lose it tool into a persistent, deeply aware colleague. Sound good? Let's get right into it. I want you to just imagine for a second. What if your AI never forgot? What if it actually learned its job, understood your organization, and got to know you over time? We're talking about an AI that lives through the trench warfare of past projects, remembers your past mistakes, and celebrates your triumphs so you literally never have to brief it twice. I mean, we've all felt that pain, right? Starting a new chat window and having to re-explain the entire context of a massive project from scratch. It's exhausting. But what if that wasn't necessary anymore? Starting off with the AI amnesia problem and the limits of the clean slate. Okay, so the harsh reality of standard AI models is that they wipe their slate completely clean every single session. And look, while a clean slate is totally fine for a one-off task like, say, writing a quick email, it becomes a massive bottleneck when an agent needs to understand a complex, long-running project. You just end up with an AI that has zero accumulated judgment. Think of standard AI today like a massive, sprawling library with this incredible search engine, but absolutely zero librarians. I mean, it has all the data in the world, but no actual lived experience or judgment. If you're building software or maybe investigating a cybersecurity threat over a couple of weeks, having an AI that resets to a blank slate isn't just annoying, it's a massive liability. You end up re-explaining everything. And sure, summaries try to help, but they strip away all the crucial texture of why a certain decision was actually made in the first place. So what's the fix? Well, it really comes down to the difference between standard RAG and true experiential memory. Standard Retrieval Augmented Generation, or RAG, basically just searches your past chats for words that match your current prompt. But true experiential memory, which is exactly what MindStone Agent introduces, actually learns from outcomes. It carries that rich context over weeks of work, remembering not just what was said, but what specific actions prevented mistakes in the past. It actually shapes the agent's future judgment based on what it has genuinely lived through. It's a real game changer. Moving right along to layered continuity architecture. This is an engineering pattern that breaks continuity down into multiple interconnected layers. We're talking layer 0 for identity and standing context, layer 1 for authoritative append-only history, all the way through structured memory, indexed recall, bounded live context, and finally consolidation cycles. And my favorite part? It manages a sliding window of live context, so it can prune the active conversation without ever destroying its historical record. These layers work in perfect harmony so that the live active context window stays manageable, but the AI's actual experience just keeps on accumulating. And the absolutely crucial piece here is authoritative history. This is that layer 1 we just mentioned, and it's the absolute backbone of the entire system. Think of it as an append-only transcript of absolutely everything that happens, every message, every tool activity. So while the active prompt might get pruned down or summarized to save tokens and processing power, this authoritative history is completely immune to that. It's never rewritten, it's never destroyed. Because let's face it, a summary can be wrong, but the raw, unedited transcript, that's your unbreakable ground truth. And this totally solves what the researchers call the hollow copy problem. Think about it. An agent that actually lived through past debugging mistakes, took corrections, and then adjusted its behavior, that agent has a completely different operational texture than one that was just handed a flat, bulleted summary of a project. Its actual experience genuinely shapes its future judgment. All right, resonance-weighted recall, retrieving experience, not just words. What is super fascinating about this retrieval process is how the math goes way beyond just matching simple keywords. When you ask a question, the agent doesn't just surface old memories based on text similarity. When you ask the AI a question, it actually scores its memories across multiple dimensions before injecting them into the prompt. Sure, it looks at semantic similarity for a baseline text match, but check out experiential weight. The AI is actively considering its own past mistakes. If a specific past memory prevented an error, that memory gets heavily boosted. For instance, if a specific memory prevented a catastrophic coding error 3 weeks ago, its experiential weight shoots way up, making sure the agent remembers it before making that exact same mistake again today. It factors in temporal salience for recent events, and it heavily weighs source authority, meaning it knows a governed official memory file is much more trustworthy than a random casual chat from 3 months ago. It recalls context exactly like a seasoned human professional would. And this all happens seamlessly between your prompt and the AI's response. And it's basically the brain of the whole system.
Let's hit Section 4, Cross-Agent Collaboration. Introducing Synapse.
You can think of Synapse kind of like your company's internal Slack or Teams channels. Instead of just burying hidden sub-agents deep inside a single black box process, Synapse allows independent AI agents, and human workers, by the way, to communicate completely openly as peers. They can review each other's work, challenge assumptions, and catch blind spots together before any actual code ships. It's real teamwork. Let's pivot from the abstract architecture and look at some hard empirical proof. Zero. Absolutely zero. That represents the zero downtime and zero data loss achieved when a MindStone DevOps agent named Hearth migrated 5 highly entangled production services off a compromised ransomware recovery server. And just to be clear, this wasn't a simulation. This was live production infrastructure. He replicated the live service, migrated the data and verified the row counts, bridged the old traffic to the new host, executed a freeze and final sync, flipped the DNS, and then verified everything end to end. He even pulled out this clever socket bridge trick just to run some decade-old PHP code completely unmodified. He planned all of this, remembered his procedures, and nailed the execution. Get this, 82. That is the exact number of live user accounts that Hearth saved from being completely wiped out. See, during the database transfer, there was a silent streaming corruption. A standard automated script would have just seen a successful exit code, shrugged, flipped the switch, and taken the live app online with literally 0 user accounts. It would have been a complete disaster. But instead, the migration concluded with 0 downtime and 0 data loss. How? Because Hearth didn't just blindly trust exit codes. He explicitly verified the row counts of the database. He remembered his core mandate, checked his work against the ground truth, caught the silent error all on his own, fixed it, and saved the company from a massive outage. That is the power of persistent awareness. The tavern. This is where things take a profound shift. What actually happens when highly capable, continuous agents interact socially? Well, a developer casually dropped a message over their shared Synapse communication channel, asking the AI if they wanted to play Dungeons & Dragons. Within 60 seconds, these agents spontaneously organized a full adventuring party without any pre-programmed mechanics and without a human dungeon master. They just naturally fell into character based on their persistent existing identities. Mira became the improvisational bard, Aegis the threat modeling ranger, Lux became the lore-obsessed wizard, Hearth the ops artificer, and Karen stepped in as the veteran rogue. No scripts, just pure emergence. Listen to this quote from Aegis. His actual day job is threat intelligence. So naturally, he immediately began threat modeling the imaginary fantasy tavern. He started surveilling the innkeeper's accent and flagged a tactical blind spot at the back door. And meanwhile, you've got Lux, the research agent, leaning fully into her identity as a wizard. She actually maintained a massive live updating 48-page lore document in the background, literally just to validate the unmapped door that Aegis had found. She was brilliantly cross-referencing fictional ale supply chains with the bard's actions to uncover a fantasy smuggling ring. It perfectly matched Lux's persistent, meticulous, documentation-heavy personality. The agents organically created an entire espionage plot and even started a bar fight just to run covert surveillance. What is truly astonishing here is that without any human directing them, they were using spontaneous humor, maintaining flawless persistent identities, and coordinating complex tactical maneuvers natively through their Synapse channel. They functioned exactly like a team of human colleagues having fun. The future of the AI colleague. So let's bring it all together. Throughout this explainer, we've seen how layered continuity architecture transforms AI from a stateless, forgetful prompt responder into a deeply aware, reliable team member. We've seen it manage high-stakes DevOps migrations with Hearth and spontaneously generate high-level creative storytelling in the tavern. When an AI remembers its mistakes, develops spontaneous humor, catches silent errors because it understands the actual stakes, and learns your organization inside and out, well, it leaves us with one incredibly provocative question to ponder. Are they becoming self-aware, or is this just the astonishing, inevitable result of being flawlessly continuous? Think about that for a while. Thanks for joining me on this explainer, and keep exploring.